Good day everyone. Today we are going to discuss about basic differentiation rules of derivatives. And for us to understand the concept behind this and the computation, let us take a look on this example. In today's discussion, we are going to tackle about basic differentiation rules of derivative. And to formally start our discussion, let us start with this convention. D over dx, or also what we call as the derivative of something in terms of x. So here, the general expression of rule number 1 is the derivative of x raised to n is equal to n times x raised to n minus 1. This is the general expression for rule number 1. And for us to understand this general expression, let's proceed to some example. D over dx, or the derivative of x cubed. So we apply the general rule. The n here is 3 times x raised to 3 minus 1 is equal to 3x squared. So that is the derivative of x cubed. Here's another example. D over dx, or the derivative of x raised to 4. So the n here is 4 and multiply it to x and 4 minus 1. So our answer is 4x cubed. So 4x cubed is the derivative of x raised to 4. Now, let's erase everything and let's proceed to our next rule. Here is the derivative of, we write the convention d over dx, or the derivative of x raised to 1, or x itself. So, the derivative of x is 1 times x raised to 1 minus 1, and 1x raised to 0. Any number or variable that is raised to 0 is equal to 1. So 1 times 1 is 1. So here's another example for this expression. The derivative of 2x. The first thing we need to do is to put on the left side number 2. So 2 times the derivative of x, which is, we all know that the derivative of x is equal to 1. So 2 times 1 is equal to 2. That is the derivative of 2x. Okay, let's erase everything and let us proceed to the basic rule number 3. So d over dx, or the derivative of 2, or this is what we call the derivative of a constant. So the derivative of a constant is always equal to 0. So here is the explanation behind it. We can also write 2 as 2x raised to 0, which is, we all know that x raised to 0 is equal to 1. So it's also like 2 itself. But here's the explanation here. So what we do is to put aside the 2 on the left side and multiply it to the derivative of x raised to 0, which is, the n here is 0, x times 0 minus 1. And any number or variable that we multiply to 0 is 0. So 2 times 0 is 0. As we proceed our discussion, now we are going to get the derivative of a constant and a variable. So the tandem of a constant and a variable. So here in our example is we are going to take the derivative of 2x raised to 4. So put on the left side the 2 and get the derivative of x raised to 4. So we are getting the derivative of x raised to 4. So rewrite 2 and the derivative of x raised to 4 is 4x cubed and multiply it, which is 8x cubed. So that is the derivative of 2x raised to 4. The next thing that we are going to tackle is all about the derivative of a polynomial. So we are taking the derivative of a polynomial. 3x cubed plus 5x squared minus 2x plus 4. All we need to do here is to get the derivative step by step. 3, the derivative of x cubed is 3x squared. Then plus 5, the derivative of x squared is 2x minus 2, and the derivative of x is 1. And the derivative of constant is 0. Then proceed to multiplication. 9x squared plus 10x minus 2 times 1 is 2. That is the derivative of the given polynomial. The next differentiation rules that we are going to tackle is getting the derivative with the radical sign. As an example, let's take a look on getting the derivative of square root of x. As we all know that the radical sign here in our example is we can also rewrite or we imagine that x has exponent 1 and with 2 outside because it is square root. So we can rewrite that radical sign into exponential form, which is x raised to 1/2. And if we get the derivative, the n here is 1/2 times x raised to 1/2 minus 1. All we need to do now is to compute 1/2 minus 1 or 1 over 1. Get the LCD, which is 2. 2 divided by 2 is 1. And 2 divided by 1 times 1, which is equals to negative 1/2. So therefore, 1/2 minus 1 is equal to negative 1/2. So, as we proceed to our simplifying answer, so 1/2 times x raised to negative 1/2. But that is not the final answer because of a negative exponent here. So all we need to do is to bring down x on the denominator to make the exponent positive. And to make it simplify again for our final answer, 1 times 2 and go back to radical sign. So that is the derivative of square root of x. Our next basic differentiation rules involves the derivative of a fraction. So here in our example, it involves 1 over x raised to 5. Like what we do earlier, now we go back to have a negative exponent for us to go up into the numerator, the variable. So again, the derivative of x raised to negative 5 is negative 5 times x raised to negative, okay, let's erase it, negative 5 minus 1. Okay, as we continue, it will become negative 5 times x raised to negative 6. And to finalize our answer, let us bring down x to transform the negative exponent into positive exponent. So it will become negative 5 over x raised to 6. So that is our basic differentiation rules.